Hey everyone, all right, so we're going to talk about how to solve quadratic equations by factoring. So we spent a lot of time factoring. We're going to use a lot of that information and a lot of those steps and those practices to actually solve for quadratic equations. So the first thing I want to review is this idea of finding a product and it being equal to 0. So if we say we let some numbers A and B, we let them be real numbers, okay? So if we have A times B, and that product is 0, okay, that product is 0, then one of the numbers has to be equal to 0. So it's either A is equal to 0, or B is equal to 0. I mean, it's possible they both could be 0, but we're really looking for A or B, either or, so two different solutions. Okay, so A equal to 0 or B equal to 0. So when we talked about this when we did graphing, we said that really when we're looking for something multiplying to 0, we're trying to figure out where we're crossing the x-axis. So we're trying to find our zeros, we're trying to find our solutions, we're trying to find our roots, okay, we're trying to find our x-intercepts. So the whole goal of us trying to solve by factoring is so we don't have to graph it every single time. We have all these other methods, and at the end of the year you are going to be asked to show how to do that. So that's the other reason we're doing it. So example 1, okay, solve the equation. We have y minus 2 times 5y minus 4. So whenever we've done factoring before, if it's not already factored, we say, do we have a GCF? Okay, so it looks like y minus 2 and 5y minus 4. Those are factored pretty nicely. There's no GCF. And then you would ask yourself, okay, if I don't have a GCF, can I factor any more? Okay, can I factor, am I done factoring? And here, there's no more factoring that needs done. So at this point, when you have nothing else to factor, you need to ask yourself, okay, so for this first binomial, what does y have to equal so that this whole thing will equal 0? Okay, so that's the question. What does y have to equal so the whole thing is 0? So the answer to that is by, you can find that by setting it up. Setting it equal to 0, plus 2, and then solving. So here you could say, well, if y is 2, that would make my first binomial equal to 0. So the same idea for the second one, because you do have a product between them, okay? So for this whole setup, what could y equal so that the whole thing is equal to 0? So again, same process. We're going to take 5y minus 4, and we're going to set it equal to 0. Okay, and so we go through our solving equations. So we should be able to, at this point in the year, be able to solve a two-step equation. So we add 4 over, we divide by 5, and we get two solutions. So when y equals 2, the first binomial equals 0, and when y equals 4/5, the second binomial is equal to 0. So that's what makes the whole thing 0, and that's your goal, is to figure out what product, what combination of numbers will give you that 0 that it's equal to. Okay, so I want you to real quick try the U-try based off what we talked about, see how you do. Okay, so go ahead and do that now. So for this problem, you should notice when you go and ask yourselves, okay, is this completely done factoring? Like, are you done with it? Do I have a GCF? You should notice that this second binomial actually does have a GCF. Okay, so you can say yes to that question. but you don't need to worry about it right now. But if you do notice that when you go to the step 2, are you done factoring? If you are doing the work, you should have pulled a 3 out of here. But when we're solving, so you would have lost points on the factoring process, but when you're solving, you do still get the same answer. So just for right now, make sure you're still doing all your steps correctly, because this should have been factored a little further. But my main focus right now is, did you get those numbers for x? So for the yellow, 2x minus 3, what does x have to equal so that the whole thing is 0? So when you separate it and solve, you should be able to say, well, when x is equal to 3 over 2, then that whole binomial, the whole yellow binomial here, is then equal to 0 and makes the whole thing 0. So then the green one, same idea, when you separate it and solve, you should be able to tell me what this whole thing has, the x has to be equal to, so the whole thing is 0, and you should get -2, which means on a graph, these are our x-intercepts, there are roots, they are solutions, because these are all the words, and these are our zeros. So if you don't know those key words, those all mean one thing. So I want to show you what that looks like so you can see. So I'm going to go to my calculator. I'm going to type in exactly what was given to me. Okay. So I'm going to type in 2x minus 3, and I'm going to type in my 3x plus 6. So I should get this graph. As you can see, it's not, the window needs adjusting. So I'm going to adjust my y. So hopefully I can show the whole parabola. Okay, so right here. So you don't necessarily have to show the parabola, because what we're about to do is in the calculator, if you hit second trace and you go to 0, we can now find our zeros in the calculator. And I want to show you this first one, because the first one's a little easier, or no, the first one's a little easier to see. So we should have a -2, and you can see it crosses right at -2, but we're going to use the calculator to verify that. And we're going to talk about that more in class, just so you can see how it's related. So you can see my 0 where it crosses the y or the x-axis is at -2, 0. And I bet if I do this again, I'll show you how to do this in class, like I said. If I do this again, this one should be that positive 3 over 2, which is 1.5. Okay. So real quick, 1.5 is also 3 over 2. Okay. So that's how graphing and factoring, we've talked about it already, how they're related, but that is also how, just a reminder how you can do it and how you can verify. So the numbers we're getting for x here in the u-tries and the examples should also be the answers we get in our graph. So for example 2, we have something a little bit different. We have 2a squared plus 26a equals 0. You should always make sure that it's equal to 0. If it's not equal to 0, you need to make it equal to 0. So at this point, it's equal to 0. Do we have a GCF? And you should be telling me, yes, I have a GCF. My 2 and 26 are even, so they at least have the number 2 in common. My a squared and my a should have an a in common. So if I take out a 2a, my first term, to get 2a squared, I should have an a in my first spot, so that 2a times a gives me 2a squared. Okay. So then for 26a, if I take out an a and I take out a 2, that leaves me with 13. So then when I distribute, 2 times 13 is 26, and then you have the a that follows. Okay, so that should be what it looks like. So now, is this factored all the way? Are you done factoring? That's what you need to ask yourself. Do you have more factoring? Do you have to do trinomial? Do you have to do difference of two squares? Do you have any of that you need to do? And we actually don't. We are completely factored. So this one's a little bit special. because we have our GCF out front with a variable, and we have our binomial here. So we don't have two binomials, we have a 2a, which is a monomial out front, and then the a plus 3, which is a binomial. So whenever you have something out front that's with a variable, with a letter, okay, with a variable, you will then set that equal to 0 and solve, because a could be 0. We need to figure out if there's other numbers that make it 0, but 2 times a can somehow, if that can give us 0, then we need to check it, okay? So here, if we solve for a, the only way we can get 0 is if a is actually 0. So that is going to be one of our solutions. So for the binomial, we need to figure out what a has to be for the whole thing to be 0. So when we separate it from our product here and set it equal to 0, we're going to subtract our 13. And we have a here is negative 13. So that makes sense though, because if you have a positive 13 and a negative 13, they should add up to 0. So my roots or solutions or zeros here, my answer should be a equals 0 or negative 13. Okay, so I want you to do a similar problem with the U-try listed below, so go ahead and do that now. All right, so for this one, you should have said that you had a GCF, and you should have noticed that this was already equal to 0, so you could move directly to GCF. So our GCF here is actually x. So if I take out an x, I should be left with x minus 5. And then because x is a letter, and this is a product that's happening between the x and the parentheses, you do need to take x and figure out what would you put in there so that it equals, it would make the whole thing equal to 0. So here, x would just equal 0. Okay, so that should be one of our answers. So then we take the binomial and do x minus 5, and we solve for that to figure out what x has to equal so that the green, the binomial here, equals 0, and that would be a positive 5. So for this, we can say that our roots, solutions, our x-intercepts, and our zeros, because they're all the same thing, are 0 and 5. So I want to, again, take a look at the calculator to show you what that looks like. So x squared minus 5x, okay? I should have my parabola, looks something like this. I'm gonna make my window normal looking. So you can see it crosses your x-axis through the origin right here, and it crosses here what looks like at positive 5. So 1, 2, 3, 4, 5. So when we practice the calculator part in class, we can extra verify that this is at 0 and that this is at 5. Okay, so those are our two answers because that's where it crosses the x-axis. Okay, we're gonna do, we're actually gonna stop there because I think if we do another example, it'll get a little long. So we're gonna go ahead and stop the video there. Have a good night.